Welcome back. Now we are going to do problem number 2 for the review of our exam. So let's do problem 2. So far we have looked at the mathematical aspect of solving a differential equation using Laplace transformation. Now we would like to apply that concept to a system. Okay. So let's say we have an open loop system here with a transfer function of g of s, and the input going into the system on the left hand side is your input. This is the r of s. Let me call this as an input here, and the output coming out of this block is c of s. So now, suppose if I am given the system in terms of a differential equation, let me write this as a differential equation, and let's say it's a very simple differential equation where we have dc of t dt plus, let's say, 4c, and this is equal to the CFT. 4c is equal to the input, which is the reference input. We are going to call it r of t. This is all in time domain, isn't it? This is a differential equation. We are trying to, the goal is to take that differential equation, so this is given of a system, and from this what we want to do is we want to find the transfer function. So same kind of concept, but we are now talking in terms of a system. Okay, so given the differential equation, we are going to find the transfer function. Again, we are going to assume that the initial conditions are 0. Alright, so let's do that then. So here we are going to take the Laplace transform of this given differential equation. So here we go, dc of t dt, and this is for c of t. Hopefully this will not be that bad. Laplace of that is equal to Laplace of r of t. There you go. So now if I am going to take the Laplace transformation of that, remember that table that we've been talking about, so this is going to be just simply as c of s. Now recall that the initial conditions are 0 in this case. So this is going to be 4 c of s, and this is just simply going to be r of s. Well, here we go. So we can factor out c of s from here, and you will have what? You will have s plus 4 is equal to r of s. Well, it appears that to find a transfer function of the system is not that difficult now, right? Because we got these tools. We got the tool of the Laplace transformation at our hand, right? So cs over rs, the open loop system, is going to look like this transfer function, 1 over s plus 4. So if I were to put this in the block for this system representation of the transfer function, I could put this guy in here. Let me call this guy g of s is equal to that. So the input going into the system, sometimes they call this as a reference input, if you will. As we go further, you will learn all about that, okay? And this is called the output. So this is your c of s. And inside, what you get is 1 over s plus 4. And this is what we call is a transfer function. So what we did in this problem was essentially given the differential equation of a system, we try to convert it into the transfer function in S domain. In the next problem, in the next video, what we are going to do is we are going to put some reference input signal as a unit step function, and then try to find the response of the system in the time domain. So I will see you shortly in the next video. Thank you.